Hi, everyone. We're going to go back to sections 4.2 to 4.4 and do some of the parts we skipped earlier. In part F, we're going to talk about how we can use inverse trig functions to solve an equation like this, sine of theta equals 0.4. Now, I need to make a point first, and I'm going to go all the way back to factoring from section 2.5. So in section 2.5, let's say that you run into your old algebra teacher in a dark alleyway, and your old algebra teacher asks you to factor x squared minus 3. Now you should ask your algebra teacher over what set, and then maybe your algebra teacher will dissolve and disappear, because the answer will differ depending on what set of coefficients will be legal. If you try to factor this old school over the integers, like you may have tried to do in your old algebra class, guess what? X squared minus 3 is prime over the integers. You cannot break this down any further if you're only allowed to use integer coefficients. But if you're allowed to use the whole swath of real coefficients, if you're factoring this over R, the set of real numbers, this does break down. You can think of this as a difference of two squares, and this factors as, remember, x plus root 3 and x minus root 3. So you see, the answer to this factoring problem depends on what set you're allowed to factor this over. What are the coefficients that you're allowed to use? Well, likewise, when we asked, how do you solve sine of theta equals 0.4? You need to ask on what interval. On homework or exams, I hope to make that clear. Now, in general, if you're asked this on a general test, then we assume that you want all real solutions. But for now, let's be careful about the interval of values for theta that we're really looking at. So you want to ask on what interval. Solve this equation on what interval? That is, on what interval of values for theta? These potential solutions for theta. Okay, first off, let's solve this trig equation on the open interval from 0 to pi over 2. In other words, we're going to find the acute solution or value of theta that will make this work. What is the only acute angle in radian measure such that sine of theta equals 0.4? There's going to be one acute solution here. Remember, your answer to a solve an equation problem is a solution set, and I claim that you will only get one acute solution. We will have a solution because 0.4 is a legitimate sine value. It's in the range. If we had a 2 or a 3 here, then the solution set would be empty. But here we will have one acute solution. Well, let's look at the unit circle. Let's look at the unit circle. All right. On the unit circle, remember that sine of theta corresponds to y. Sine of theta corresponds to the y coordinate on the unit circle. Now, where on the unit circle is the y coordinate, the sine value, equal to 0.4? Let's say over here and over here. So in general, there will be solutions to this in quadrants 1 and 2. But wait, we only care about solutions in this narrow interval. We only want the sole acute solution to this equation. So we only want the acute angle, the acute representative for this point over here. Sine of theta equals 0.4 has only one acute solution. This angle. We want this measure for theta. And how would you calculate this on your calculator? How would you find the measure for this acute angle? Well, it depends if you're in degree mode or radian mode. Make sure you're aware of what mode you're in and how to go back and forth between the modes. But it turns out that If you're in degree mode, when you work out the inverse sine of 0.4, and that's what you have to calculate, the inverse sine of 0.4. We have to calculate the inverse sine of 0.4. The inverse sine or arcsine of 0.4, which we know will be an acute angle. Now in degree mode, we're going to get 23.6 degrees. In radian mode, you're going to get 0.412 radians. Now let's check to see that this makes sense. So I'm claiming that over here, the corresponding angle will be about 23.6 degrees, or about 0.412 radians. And remember that the y-coordinate, the sine value, is 0.4. Well, it makes sense that the angle here is less than 30 degrees, because for 30 degrees, I'll put that in purple, for 30 degrees, this might be a bit too steep for 30 degrees in reality, but for 30 degrees, remember that the sine of 30 degrees is 1/2, or 0.5. I hope you remember that. The sine of 30 degrees is 0.5. Well, if the sine of 30 degrees is 0.5, if this is 0.5 up here, I know it's not to scale. If the sine of 30 degrees is 0.5, it makes sense that the sine of a smaller angle, in this case about 23.6 degrees, will be 0.4. And 0.412 radians will be a bit less than pi over 6 radians, which was 30 degrees. Okay, so this answer makes sense. If you're asked to find the acute solution for this equation, remember the answer to a solve an equation problem is a solution set. There's only one solution that's acute, and it's about 0.412 radians. I'm going to use radian measure here. Although when answering a problem, make sure that you're answering using the appropriate unit, whether it's degrees or radians. What is it you're asked for? The hard part is not going between degrees and radians. The hard part is knowing what to do. How many solutions do you have, and where are they? So this equation only had one acute solution. But now, let's ask a second related problem. What are the solutions to this equation on this interval, basically between 0 and 2 pi? That is, find the solutions, values for theta, around one classic revolution around the unit circle. I have a parenthesis here because, remember, 2 pi is coterminal with 0. All right. So let's see what happens there. Between 0 and 2 pi. So this time, we're going all around the world once. In terms of looking for solutions, we're going to look around the unit circle in terms of looking for solutions. All right, from 0 to 2 pi. What are the solution values for theta we pick up? All right. Now, again, we want to find angles whose sine value is 0.4. And actually, I can appeal to this picture back here. Again, we're looking for 2 points whose y-coordinate is 0.4. I should probably lower this a bit. 2 points whose y-coordinate is 0.4. All right. So between 0 and 2 pi, how many angles are we going to pick up? As we go around the world, as we go from 0 all the way around to 2 pi, not quite 2 pi, what angles do we pick up? Well, we pick up the same acute angle that we did before, the whole 23.6 degrees or 0.412 radians. In fact, I can copy this. So we get this acute angle over here, but wait, we also have this supplementary angle over here. It's a brother, a coreference angle. They have the same reference angle, namely this. Now, how can we get a measure for this supplementary angle in quadrant 2? Well, in degree mode, you would do half a revolution, 180 degrees, minus the reference angle, which was the 23.6 degrees. So the supplementary brother in quadrant 2 that we want will be about 180 degrees minus 23.6 degrees. That's about 156.4 degrees. So in degrees, that's going to be this degree measure for this solution. In radian measure, you use pi radians. Instead of 180 degrees, you use pi radians to represent the half revolution. Pi minus 0.412 is about 2.730 radians. So again, in quadrant 2, the solution that we want will be about 156.4 degrees, or about 2.730 radians. I have the right to put that 0, so I'll put it in. I'm going to put these out to 3 decimal places. All right. So in radian measure, our 2 solutions will be about 0.412 radians and about 2.730 radians, this quadrant 2 angle, which is still between 0 and 2 pi. It's obtuse. So in solution set form, if we want the solutions between 0 and 2 pi, there are 2 of them. One is about 0.412 radians, that's the acute quadrant 1 solution, and one is about 2.730 radians, that's the obtuse quadrant 2 solution. And this kind of analysis will help you on the homework. It's harder when this value over here is negative, then you really have to think. When in doubt, think about the reference angle. So even if the reference angle itself is not a solution, it's still a good thing to build things off of, because it's easy to get from the reference angle to key brothers in the other quadrants, whether you're in degree mode or radian mode. Now here's a preview of chapter 5, namely section 5.3. Solve sine of theta equals 0.4 on R, the set of all real numbers. Let's find all real solutions. That's going to be a chapter 5 problem. So what do we pick up? Well, as we go around the world, we pick up our 2 solutions from before, from question 2, but we're allowed to go around and around and around and around, both counterclockwise and clockwise. So we want not just these 2 solutions, but all of their coterminal twins. So we want this, also this, plus 2 pi, plus 4 pi, and so forth, also minus 2 pi, minus 4 pi, and so forth. We want this obtuse solution, and also this guy plus 2 pi, plus 4 pi, and so forth, and minus 2 pi, minus 4 pi, and so forth. So we can take these guys and add or subtract integer multiples of 2 pi. This is how we'll write our approximate solution set in chapter 5. It's this long thing. The solution set is the set of all theta in the reals such that theta is about 0.412 plus 2 pi n, where n is integer, or theta is about 2.730 plus 2 pi n, where n is integer. Again, we want this acute solution and also all the coterminal twins. N can be negative as well, a negative integer. Also, we want 2.730, this obtuse solution, and also its coterminal twins, where n could be 0, a positive integer, or a negative integer. So in chapter 5, and specifically in section 5.3, we're going to solve trig equations on R, and we're going to get all real solutions. Typically, we'll get infinitely many solutions. Sometimes, like for sine of theta equals 2 or 3, we'll get the empty set. You'll get lots of practice on the homework. So that's section 4.7, including a rollback to 4.2 to 4.4. Next, we'll discuss word problems.